Okay, here we go. Applications of the dot and cross products. That's what it is. Okay, the first one we're talking about is torque. Torque is the amount of force upwards or downwards. Applied by rotation. So the magnitude of torque equals magnitude of R, magnitude of F, sine theta, where R equals radius, F equals force. So the magnitude of T is equal to R cross F. Is the magnitude of R cross F, I guess. Okay, another thing as far as the direction, we didn't talk much about direction, but the direction of the orthogonal force is like opening a bottle. You guys ever hear of, I was heard lefty loosey, righty tighty when you're opening or closing something? That's because of torque, okay? So if you're going to be opening something, so upward force is counterclockwise. Downward force is clockwise. And you'll hear in physics class, right-hand rule, they try and make it really complicated. Okay, but the easiest way to think about it is just opening or closing. So again, do you mind if I borrow your water for a second? Someone's going. So again, just think of torque like this, okay? I'm going to open this up. So if I want to open this up, that means the force is going to go upwards. I'm just going to turn it, maybe. You're a lot stronger than I am, apparently. I'm not going to do it now. You're supposed to turn counterclockwise, though, to open this up. I think embarrassed your teacher in front of the whole class. Is
F a vector the whole time?
Yes, we're going to say force will be a vector in this case, too. Thank you. Oh, it's good. Yeah, well, it's going to be, because again, you're treating them like vectors, because it's both going to be based on from the center point. That's what we're going to say. Thank you. The other thing we're going to say is to increase the torque, you can either A, increase the force. So when I was trying to open up Michael's bottle there, I started doing this, trying to open it up, okay? And the force, I wasn't getting enough force, okay? The other thing I could have done, and this is what you'll see often with wrenches and things like that, if you increase the distance that you're using, it becomes a lot easier to do. So part B would be increasing the radius. Distance of the force applied. And there was a guy, I'm trying to remember if it was Aristotle. Was it Aristotle that said the lever thing? If he had a lever, it was so big he could move the whole world. Is that the right guy? Maybe not. Was who? It might have been. I can't remember who it was. My mind is not working today for details, but there was somebody who said that though, right? The idea was that he had big enough lever, big enough stick, he could move the whole world. That was his sort of. It's like, anyway. All right, let's get to an example here once Chris gets things written down. Welcome, Chris, by the way. Oh, he's in the zone. Right? He can't be shaken. He's in the zone. How'd the test go yesterday, guys? So wait, let me hit pause on the video first so you guys can there. Hold on a second. Same page, please, okay?
I'm done with the left-hand page.
Okay. So here we go, example 1. On Monday, I will give you guys a review sheet that will list all the potential formulas you need to know. Like I'll put on here what torque is, what to use for crossing and dotting and all that, and things you have to be responsible for. If on the test I asked you a torque question and you do not know what to use, it'll cost a mark. I can't remember when to do that to you. It'll cost a mark to get your point in the right direction. Okay? What do you mean no?
Think about it. It's just
It's evil that I'm giving this to you. That's what's evil. I bet the math teacher's gonna laugh at me. A force of 80 newtons is applied at 70 degrees to the handle, 25 centimeters from the center of a bolt. Clockwise. What is the magnitude of the torque? And in what direction? Okay, let me get out of the way here. So, sorry, go ahead.
What unit is radius?
Meters, that's the thing, it's gonna be in meters, so I'm just gonna make a point about that. This is one of these things that math teachers are, gonna trick you for here, okay? All right, can you be brave, please, and sub some numbers in for me, please. So I'm gonna write here, torque, magnitude of torque equals Can you sub some numbers in for me, please?
Yours is 25.
Yeah, I'm going to call this one 0.25 though, and this is what I was saying math teachers are going to be mean because we're going to use, it's going to be in meters, it's going to be what the unit is. Okay, force is?
80.
80. And this theta is?
70.
All right, Nicole, V squared. Can you use the great power of your calculator and calculate that for me, please? And when I say Nicole, I mean everyone. Thank you. So the magnitude of the torque is 18.79, which is 18.8. Oh, I don't have a unit here. I'm going to just leave it as 18.8 because I don't want to write it down. I want to say it's Newton meters. I want to say, what's a Newton meter? I don't know what a Newton meter is. A joule, a Newton meter. Is that Newton meters, a joule? Maybe not. I'm just going to leave it as that then, okay? Now, here's the thing. Because it says, can we go here, please? Because it says clockwise, are we pointing, is it going to be tightening the bolt or loosening the bolt?
Downward.
Downward, okay? So the direction is downward, so it's going to be tightening the bolt. And again, if you're stuck on this in physics class, I can't believe I'm telling you to cheat in physics class. Bring yourself a bottle of water to the unit test. Okay, and that'll tell you which way the torque is going. All right, it's not legal to run a motor loaner.
But what if it was like a model with the wrong thing, and then you just print out all the answers?
And then that's illegal. So it's illegal. Okay, hold on, guys. Stay with me here, please. Go ahead. All right, here we go. Projections. We're going to say projections in 3D. Are the same as in example 2. And you guys are going to do this one for me once Luke gives me the first step. If vector u is equal to 2, -6, and 8, and vector v is equal to -3, 4, and 5, find the projection of v onto u. Okay, this question or something like it will probably be on your test. So if you are fading, sitting at the back, I'm sorry, you're not fading. Okay, but if you're fading, sitting there, this is the time to fade in. Luke is looking through his notes, which is perfect. I love it. Okay, I was going to just pass on Luke, but he looks like he's engaged here right now, so I'm not going to.
Yeah.
Luke, did you find what the projection is? Do you remember?
Is it the projection like V onto U is bracket V dot U over U dot U?
Awesome.
And then bracket U.
Good. Okay, so I'd like you guys, please, hold on, please. I'm going to hit positive there, I'd like you guys to try this out now. As far as the dot, for Derek, am I going to be using the cosine version of, or am I going to be using the UX, VX definition here?
Be using the UX version because we are given all of the.
Yeah, you're given these in terms of, your two equations being given here, so you can easily cross those out any angles in there, okay? Or easily dot those. I'll hit positive in there. I'd like you to try that for me, please. Thank you, Luke, for your answer. That was excellent. I'm going to pause this. If you're saying, Mr. Sadler, I don't know how to